Good evening, everyone. We are in the week 6 problem solving session of the NPTEL course Network Analysis, and week 6 is about circuit analysis with Laplace Transform. I am Teja Golla, a fourth year research scholar working under Dr. Sandra Kapat at Embedded Power Management Lab, EE Department, IIT Kharagpur. Let me share my screen. Are you able to see my screen?
Yes, sir.
Okay. So, as you know, this week is about circuit analysis with Laplace Transform. But before that, I would like to give you why we use Laplace transform, and why do we need to learn another method if we have already learned phasor in the last week, and we have learned in the previous week, which is week 4, we have learned how to solve linear differential equations using that characteristic polynomial, and then finding the roots, and then exponential, general solution, forced solution we have learned. Now the point is, why do we need Laplace transform? So today's topic name is circuit analysis using Laplace transform. Circuit analysis using Laplace transform. Okay. So the first question I'll be asking is, why do we need Laplace transform if we have other methods? So why do we need? So anyone of you know why do we need Laplace transform? Like, what is the necessity or what are the benefits? Because it is equally important to learn why we are learning something. Before learning something, we should know why. Anyone?
Sir, by this method we can easily solve the circuits
Yes, very good. So
by changing them in frequency domain.
Yes, very good. So overall idea is revolving around solving a circuit, right? So solving a say RLC circuit, or solving a circuit. Solving a circuit. So this is our main objective. Okay. So under this objective, we have learned first, we'll write the differential equation, linear differential equation, LDE. So we have learned solving an LDE. Solving an LDE. And then we have used time domain, in the time domain. Okay. And then in the last week, what did we learn? We have solved using phasors, right? We have converted it into phasor domain, which is basically frequency domain. So frequency domain. Now we have two different methods, and what are the benefits and what are the flaws in these two methods? So I would not say flaws. What are the difficulties or challenges in these two methods? When we solve using time domain linear differential equation, we will be getting both transient and steady state. We can get transient plus steady state expression, right? We have seen that we get the transient expression as well as steady state expression when we solve using the time domain analysis for solving a linear differential equation. But there is an issue here. Issue is it is very lengthy, right? If the complexity of the circuit increases, then we cannot use this linear differential equation time domain analysis, because it becomes very lengthy, and the order of the system increases. It's a fifth order or fourth order, then the number of unknowns increases, and we'll have multiple number of pages of calculations. So then we went to frequency domain using phasors. So here, what is the issue? Here the issue is we'll only get steady state expression, no transient expression, right? We'll get only steady state. We have done only steady state expression. steady state expression. Now coming to solving using Laplace transform. Solving using Laplace transform. So again, this is in frequency domain. And what are the advantages? Advantages is you can easily solve the circuit. We'll see how. And we'll get both the transient and steady state expression. So that is the main advantage. Transient plus steady state. Both the expressions and in a simpler way. So you can solve in a simpler way. And why we are using this Laplace transform is, first of all, you are getting both the expressions tangent and steady state. And in a simpler way, meaning basically what happens is whatever expressions you have, the differential equation. So the differential equations will be converted into some algebraic expressions, which we'll see by solving problems. Then we can directly solve the algebraic equations, because differential terms are difficult to solve because it's time varying. Whereas in the algebraic, there is no time varying thing, so you can directly solve. So it is also in frequency domain, and the linear, the differential equation becomes some algebraic equation. So there is no need for differential equation. So what we can say, this is like the benefit. Differential equation, differential equations become algebraic equations. So then what is the advantage? They become easier to solve. Easier to solve. Another benefit is whatever theorems that you have learned, nodal analysis, mesh analysis, superposition, Thevenin, they are all equally applicable in this Laplace transform as well. So mesh analysis, nodal analysis, and other theorems are applicable as well. So if we are using this Laplace, first of all, the differential equations are becoming into algebraic equations. So it is easier to solve. Moreover, you are getting the transient as well as steady state expression. So you are solving the complete circuit. Also, you can apply mesh analysis, nodal analysis. So you can apply whatever theorems or analysis that we have learned in the past weeks in this week as well to solve the circuits. So any doubts until this point, like this is why we'll be using this and why this is important to learn Laplace transform. Any queries you have? Like I'm giving the background of why do we need this. So once we know why, then we'll move on to what Laplace transform is and how we can use. Clear? Okay. So first, although we'll not go into the details of deriving the Laplace transform of every function, but I just want to give what is the expression of Laplace transform. So usually whenever it is in S domain, you will use capital letters f of S, and whenever something is in time domain, then use small letters. So Laplace is represented by L, capital L, Laplace of f of t. So in the time domain, basically small f we are using, and in the Laplace domain, we are using capital F. And this is equal to integral 0 to infinity e to the power minus st f of t dt. So if I have some function f of t equal to t, then you have to integrate from 0 to infinity e to the power minus st into t dt to get its Laplace transform. Although we'll not go into the details, I'll give you some expressions that I'll be using today in solving the problems, and you should also be thorough with those expressions. Okay, so this is the expression. Now we have to know the Laplace transform of few standard terms. so that it will be easy for us to solve the problems. So I'm giving you a table which I have obtained online because we often don't remember the Laplace transform. Sometimes we forget, but again you have to revise because you are doing this course. But whenever you are not using it regularly, we are human beings, will forget. So, but whenever it is needed, you just have to go through it again so that you remember. So I'm giving a table, very useful table. So we have f of t time domain, and then we have f of s Laplace domain. Say it is one, input is one, or say u of t. Maybe I would say u of t. And u of t is one after t greater than zero. And also we are integrating from zero to infinity. So basically one, because u of t is one in the range zero to infinity. Then we'll have 1 by s. 1 by s. And instead of u of t, we have e to the power at. So these are all derived, and you can also derive, but the derivation is not in the part of the syllabus. But you have to remember this because every time you cannot derive in the exam, right? So there are some things that you need to remember. There are some things you need not remember. And this comes under those things which you have to remember. So for e to the power at, you will get 1 by s plus a. Sorry, 1 by s minus a. So it is 1 by s minus a. Okay. Now it is e to the power at. What if we have t to the power n? If we have t to the power n, then it is n factorial by s to the power n plus 1. Now we'll go into some sine and cosine expressions. Say we have sine 80. Then we have a by s plus, sorry, a by s square plus a square. And if we have cos 80, we have cos 80. Then we have s by s square plus a square. Similarly, if we have product of two terms, say t to the power n into e to the power 80. So let us have this term, which is t to the power n into e to the power 80. So basically, whenever there is some exponential multiplication, first you remove that. We have t to the power n. What is the Laplace of t to the power n? N factorial by s to the power n plus 1. And what is the Laplace transform of e to the power 80? 1 by s minus a. So what is there in s, you have to replace by s minus a. So for this, it will become n factorial by s minus a to the power n plus 1. Similarly, if I multiply sine 80 by e to the power bt, then instead of s, I have to put s minus b. So which is what we are going to check now. So if I multiply e to the power 80 into sine bt, so instead of s, you have to put s minus a. So we'll have a, right? So now here we have b, sorry, b by, instead of s, we have s minus a square plus b square, right? Similarly, if we do for cos, we have e to the power 80 cos bt, and then you will get s minus a, because in the numerator it is s. Now s square, s minus a square plus b square. Similarly, if we have differential term, say d to the power f, some function f small f, right? dt to the power n, then we'll have s to the power n f of s. So these are some very standard Laplace Laplace transform expression that you need to remember. I hope everyone
No,
is
one
writing these
second, sir.
expressions. Yes.
One second, sir.
Okay. So basically, I'm not deriving these. These are standard expressions. So if you want to derive this, what you have to do is you have to plug in f of t in this expression to get this f of s term. But as these are not part of syllabus and sir has not covered the derivation, I'm also not covering. But these are something you can derive and get it. There are online material also. But as this is not covered in the course, I am not covering in today's session. And also it is not needed. You just have to remember this because while solving the problems, you just have
What
to.
is Laplace transformation, sir?
Laplace transform, like basically we are, as the name suggests, it's a transform. So you are transforming something into something. What we are transforming? We are transforming a time domain expression, which is f of t here, into some other domain, which is frequency domain, and it is written by S, and it is invented by a scientist Laplace, so it is named after him, and that's why we call it Laplace transform. So initially, maybe you have not joined, so let me just summarize. The discussion that we had is, why do we need Laplace transform? We need Laplace transform because of some reasons. But before going into that, we have discussed whatever methods we have learned in the past, in the earlier weeks, to solve a circuit. First, we have learned solving a linear differential equation using time domain, where you will get transient and steady state expression. But it is very lengthy and it's also very complex terms and complex calculations. Then we have moved to phasors, which is a frequency domain, but there you will only get steady state expression, not the transient, which we have done last week. Then this week we are learning Laplace transform, which is again in a frequency domain. But using this, you can solve, first of all, solve the circuit easily, which is missing in the first method, A method. And then also you will get transient and steady state expression, which is missing in the B method. So basically the differential equation becomes some algebraic equations which are easier to solve, and also all the analysis and theorems that you have learned earlier in this course, they are also equally applicable. And the Laplace transform is defined in this way. So every time domain expression will be first converted into S domain, and then S domain will solve the circuit, and then again we'll do inverse Laplace transform to get the time domain expression of whatever current or whatever voltage that we are planning to find. So I have given some ready table that you can always access. So using this table, you will know that what is the time domain expression. If we apply Laplace transform, what is the expression? So for u of t, it is 1 by s. E to the power at, it is 1 by s minus a. T to the power n is n factorial by s to the power n plus 1. Sine of at is a by s square plus a square. Cos of at is s by s square plus a square. T to the power n into e to the power at. So whenever e to the power at is there, first you remove and write the Laplace of the rest of the term, and then replace s by s minus a. For t to the power n, it is n factorial by s to the power n plus 1. Now we will replace s by s minus a. Same in the case of sine bt, cos bt, and for a differential function of nth order, it will be s to the power n f of s. So these are something you need to remember, because these are the results by applying the Laplace transform to that, and these are something you need to remember.
How to remember, sir?
How to remember meaning that like you practice, you try to remember.
Any
Uh-huh. Sorry.
any shortcuts? Sir?
Like not shortcuts, you just have to remember. Like, how do you remember tan theta is sin theta by cos theta? Sin square theta plus cos square theta
Okay.
equal to 1. Same way. So you just practice. You read and then you try to remember and then try to write, and then do it multiple times. And once you solve the problems, then you'll be more comfortable. And anything with remembering, you have to write. You should not just read. As there is one proverb which says that writing something one time is equivalent to reading the same thing 10 times. So if you write, then you'll be remembering it much better than reading it. So that's why I usually prefer writing. So I'll remember few of these things and then I'll write. I'll then check what are my mistakes and then I'll write again. And then I'll write again until I become perfect, until I try to remember. But the more you solve the problems, the better you'll understand this concept and the more you remember these expressions. So whatever expressions that are needed in this course for these assignments, all I have listed down, so that you can always come back here and then refer these expressions, which I have also given in my last year problem solving session. So there also you can find similar one, but again I'm repeating it here so that I can refer to this in today's session. Is that okay?
Yes, sir.
Okay. So now we have learned some time domain expressions that will be that can be converted into Laplace, and we also got these expressions. Now our series RLC terms going to affect, not series RLC, RLC terms, how they are going to get affected. So first we have resistor, we have inductor, we have capacitor. So for resistor, it will be in time domain. So time domain I'll write in one color. V of t equal to I of t. As I have said, in time domain, we will use small alphabets. In the frequency domain, we'll use capital alphabets. So V of s equal to I of s into R. So R will be R itself. Whereas in the case of inductor and capacitor, it will be slightly different. So for voltage of inductor, we know that V of t equal to L into di of t by dt. So what will be the Laplace of this? Anyone using this? What will be the Laplace of
V
this?
of s equal to L di of s by dt ds.
Okay. So okay. You are not wrong, but also not right. Say I of t.
L into
The
I of s.
it is I of s. So now I'm asking for di of t by dt. What will be the expression? So you using this last one.
S I of s minus I of 0 minus.
Yes, actually, here you are very right. So here there will be some expressions which are initial condition dependent, but in this assignment they are not there. So basically here you will get minus h to the power n minus 1 f dash of 0. So some expressions are there which are dependent on the initial condition, but in this course, in this as syllabus is concerned, that is not covered. So that's why I have ignored. So assuming these terms are not there, so it will be s into I of s, right? Very good. So we'll get s into I of s using that formula. So now we'll have V of s equal to SL into I of s. So we have V of s equals to I of s into SL. Similarly, capacitor, we have I of t equal to C into dv of t by dt. So if you multiply, we'll get s into v of s. Then I'm rewriting it in this way. So I have v of s equal to I of s into 1 by sc. So if you see, all are same. Like I have written resistor, inductor, and capacitor in the same way. Only if you see here, we have resistance R. Here we have S into L, some frequency term. Here 1 by SC. So now what I'll be doing is, if I see a resistor, I will write R itself. If I see an inductor, I will write SL. If I see a capacitor, I will write 1 by SC. And I can write V of S equal to I of S into that terms, right? So basically, we are trying to convert the time domain differential equation that is highlighted in the green color into some algebraic expression. So now there is no time domain. So now there is no differential equation. So you can directly write in this domain, and you can consider, say, the impedance as R plus SL or R plus SL plus 1 by SC. So there is no time domain expression. So all are algebraic only. So if I ask what is I of S, you can write V of S by R plus SL plus 1 by SC. So there is no time domain, no differential equation business, only all are algebraic expressions. Is it clear, or any doubts you have until this point?
No, sir.
Okay, so clear, right? Everyone?
Yes, sir.
Okay. So let us quickly solve one problem before we go into, or let us cover one small aspect. So inductor with initial condition and capacitor with the initial condition. So I'll just cover one aspect which will take 5 minutes. Then we'll solve problems. So inductor with initial condition. So one thing I also want to take feedback from you. Is it okay if I take around half an hour in every week to summarize the concept, or do you want me to only solve problems from the beginning for 2 hours?
Yeah, this is enough, sir.
This is good, right? Like I should cover concept, or should I directly go into problems?
Cover concepts, sir.
Okay, okay. Say if I have an inductor, okay, say the values are L and I of t, and this is V of t, and say it has some initial condition I of 0. minus. Some initial current is there. Then, first of all, you can rewrite this as an inductor without any initial condition. In additional, I can put a current source, I of 0 minus, and this is my I of t, this is my L, and this is my V of t. So I have put one additional source and I have removed the initial condition for inductor. Both are like mathematically so same. So I can rewrite it in this way. So now on top of this, we'll change the domain. So now we are changing the domain. So from now, time domain to, we are going into frequency domain. So in the frequency domain, what will happen? So I of t will become I of s. V of t will become V of s. L will become SL. And I of 0 minus is nothing but I of 0 minus. It's a constant, right? Constant into U of t. Say like I of some 5 into U of t. What is the Laplace transform? 5 by s. Similarly, this is some constant. So we'll have I of 0 minus by s. So I of 0 minus by s. Any doubt? Any confusion?
Or if you're integrating also, we should write 1 by s and
Yes, yes, yes. Very good. So for differentiation, you will get into S. So for integration, you will get 1 by S. Yeah, that is very good. That aspect I have missed. So yeah. Thanks for pointing that. Maybe I'll write it next to it. Say if I have integral f of t, so integral f of t dt, the Laplace transform will be f of s by s. Yeah. This is also a very important thing and one should remember. I have missed it out. Yeah. Thank you. So then we have capacitor with initial condition. So capacitor, we have voltage. So similarly, we are considering one capacitor and currents are I of t, capacitance is C, plus minus V of t with an initial condition V of 0 minus. So first we'll rewrite that into a voltage source. So a capacitor with no initial condition in series with a voltage source, and things remain same. This is I of t. Entire thing is V of t because entire thing it's a capacitor, and this will be V of 0 minus, and this is capacitance. Now we are transforming the domain. Basically, we'll have capacitor, voltage source plus minus, and then now the current becomes I of s. Capacitance becomes 1 by s into c, as we have highlighted here, 1 by s into c, and then this will become V of 0 minus by s, and this overall expression will become V of s. Clear or any confusion? Because these are very much needed. We'll be solving some problems where there is some initial condition and this will be used.
clear. So
Clear, right? Okay. Any other doubts? Other people who are Amit, Gyanendra, Parvatam, Nandini, Savita, Vishnu?
No, sir.
Clear. Okay. Okay, then we'll solve problems. I'll leave this page because if there is any concept that we might cover, then I'll write there. Okay, clear. Gyanendra is saying clear. Okay, so let us see week 6. Not this.
Sir, that last week assignment, I have one doubt, sir. If
Okay,
time
if you
permits,
can. Okay, I can discuss that before we solve. Can you put a screenshot in the chat box so that I can open and everyone can see?
okay, sir.
Then I can discuss that here. So it is assignment 5. you're sending? Whoever has asked. Hello.
Sir, I will show, sir. I will.
Okay, just share the screenshot in the chat so I can open and everyone can see.
Sir, kindly enable me to share my screen, sir.
Okay, if you can put the screenshot, that would be good because I can write. Because if you share screen, I cannot have the picture, right? Because I want to write on my screen
Oh,
so that everyone can see. I can
okay.
put the like methods or guidelines to solve it so that everyone can follow. You just put a screenshot, like you can use Windows Shift S and then you can take snapshot of the question and then you can do Control V in the chat. You found how to take screenshot?
Sir, I'm unable to share, sir. I'm unable to sir, take that.
Take
I
the
have
screenshot.
take a screenshot. I have taken the screenshot, but I'm unable to post here, sir.
In the chat, you can do Control V, no? It's not
Ah,
working.
yeah, I did, sir, but I couldn't, sir. So just 1 minute, please enable. I will.
Okay, then yeah. You send a request. Or you share, I'll take screenshot and then I can do. That will also work. You should send me a request so that I can accept. I'm not getting any request. Hello. Please enable me to share my screen. But I'm not getting any request. I usually should get a request that. Uh,
Or else you open the week 5 assignment page.
because I have not downloaded it. Let me check if there are any settings. Settings. Okay. Don't know how to enable that option. I'm not sure how to enable. I'm also not getting any option for the same. Can anyone take screenshot and send? If you can tell them which problem it is, they can take a screenshot and send. Usually that's what we do. People used to share the screenshot so that I can open and everyone can see. Okay, someone has shared one link. Which question are you talking about, Parvatam?
sir, that There are two, four, fifth,
5,
fifth
right?
problem, sir. No, not 5, 6, 7, 8. That problem, sir.
Okay, let me
Question
just check.
5, 6, 7, 8.
Question 5, 6, 7, 8, 9, right?
Yes, sir.
Okay. Let me take a screenshot. Okay, I got it. Let me share my screen. There is less than a minute. I think this meeting will end. Kindly join back so that we can discuss this before we move further. Okay, what is your query in this? This exact problem we have discussed in the last week, right? Exactly same problem.
Sir, but I solved the remaining two problems in a correct method, but this one, all the answers are wrong, sir. Or I don't know why. So that's why I'm asking, sir.
Okay, but have you gone through the problem that I have covered in the last week? I have.
Yes, sir. Yes, sir. I
Okay.
tried through 2 to 3 times, sir, but again, and I got the wrong answer, sir.
Okay. I think this meeting will end. Let us start fresh. I'll draw the circuit. You match whether your circuit is correct or wrong. If it is correct, then maybe check your calculation mistake. So let this meeting end. Once we come back, I'll draw the circuit. You can cross check the circuit. Uh, that should be okay, right? Checking the circuit. I hope you are able to see my screen.
Yes, sir.
Okay, so I'll quickly draw the circuit, as now you must be comfortable with the which case it will fall under and the polarity. So there will be two sources because only two coils are coupled. 1, 2. Here also 1, 2. And here also 1, 2. So let us come back to the polarity. So this is the direction which is very important, I1, I2, and I3. So tell me, this comes under which case? And this comes under which case? Case 1, case 2, case 2.
First
Okay.
one,
Second one,
also case 2, sir.
also case 2. Yeah, very
Yes.
good. So first we'll do the self-inductance polarity, which is plus minus here, and here also plus minus, right? Because it is entering in this one. So we have J25 I1 here, and then J16 I2 here. Now because it is case 2, the polarity will be minus plus, here also minus plus, right? Because it's the opposite polarity. And here you have J14 I2, here you have J14 I1. Similarly, here the polarity is plus minus and plus minus, and for this it should be the opposite. So plus minus here and here minus plus. So coming to this, it will be J9.6 I2, and this will be J16 I3. And then coming here, this will be J9.6 I3, or maybe I'll write down. So this will be J9.6 I3, and then this is J36 I2. So is this clear?
Yes, sir.
So Parvatam, did you make any mistake in the circuit?
Yes, sir. The plus minus, I have made a mistake, sir.
Okay.
J14.
J14, okay. So both are under case 2, so there will be change in the sign. And once your circuit is correct, then there could have been calculation mistake, but now we have realized your mistake. So yeah, first circuit is the most important thing. So that's why I have emphasized so much on the circuit, but it's okay. Now you have made a mistake, so, and you have also learned the mistake. So now the probability that you'll make the same mistake again will go down, and I'm hoping he'll not repeat the same mistake in the final exam, because these types of questions are expected to be given in the final exam as well. Okay, should we move to this week problem solving session then, or any queries you have?
Sir,
Yes.
if we by solving assignment questions, can you expect the same model questions in exams? Sir?
Yes, definitely. If you see, the assignment problems that I am solving is from the last year. And if you see, Same model questions are given in this week assignment also. So whatever questions I will be covering every week in this session, you can expect the same questions in the assignment as well. Only numbers will be changed. So if you just go through my
The
lectures
exams,
and follow the same, it will be same. And also in the exam, the questions will be in the same model of the assignments. Getting
if
it?
we study assignment problems, we can
Yes.
get passed in the exams. Huh?
Yes. Around 80% questions
Okay.
will be the same. Probably there might be some different questions, say 20 to 30%, to differentiate between the people so that the grading will be done accordingly. But all 100% you cannot expect to be the same. But around 70 to 80% you can expect similar type of problems. Maybe some might be tricky, but it will not be just the copy paste that you have to understand. Say here they have given this type. Maybe they will have some resistance. Maybe here there is another inductance. Here instead of voltage source, they have current source. So some change they will make. Maybe the dot convention they will change. Here they have given like this. Maybe they have dot convention they will change. But it comes under the same like model, right? It's not just only numbers they might change. Some changes here and there they can make. Here instead of capacitor, maybe they'll have some inductor, and that is also coupled with this. So like little bit change here and there twisted, but you can expect similar model.
The
Some of the
negative
questions will
marking.
negative marking. I am not sure. I don't think it is there, but I am not sure because I'm not aware of that.
Okay.
Okay. So this week we'll solve first this question, and then the second question. This is also good question, but this question and this question are more or less same. So I'm not sure whether I'll get time to solve both, all three, but at least we'll solve two. So in this question, if you read, they are saying the switch is closed at t equals to 0. And before that, no current was flowing. So there is no initial condition. And after that, t greater than or equals to 0, they're asking what is the expression for I1 of t, what is the expression for I2 of t. If you see, they have combined last week concept of coupled inductor with this week concept of Laplace transform. Okay. And in the question, you will not see that solve using Laplace transform. The same thing you can expect in the final exam. They will not say use Laplace transform, use phasors. You should identify using which method it will be easier. And using that method, you have to solve. And now that you know Laplace transform, every question you can solve using Laplace transform. So you can solve all the problems using Laplace transform.
How to identify an exam, sir? We should solve in Laplace or any method.
Yes, like see, after learning Laplace, last week problems also you can solve in Laplace. But say they're asking steady state expression, then you can use phasors rather than using Laplace. But if they're asking time domain expression and the transient, then you can use Laplace. So if you see here, if steady state is needed, then I can use this method. But if both transient and steady state are needed, then I can use the Laplace. Or
In
for
question,
steady state also, you can use Laplace.
for the present question, it's in steady state, na, sir? Or both steady state and transient?
Both transient and steady state, because there is this time domain term, right? It is decaying with time. So this is transient expression, and A1 is steady state. Because
Okay,
at t
sir.
equal to infinity, this will vanish and only this will be there. Similarly, at t equal to infinity, this will vanish and this will be there. Clear?
Yes, sir.
Okay. So for every question, same thing. First, draw the circuit. Forget about what they have asked, what they want you to do. Forget about all those things. First, you draw the circuit. So that is the important thing that everyone should do. So please do along with me. So the circuit is closed. Here we have a resistor, and then inductor will become two voltage sources, right? Here there is one voltage source. Here there is another voltage source. And this is the input supply. Here also we have one voltage source. Here also we have another voltage source. And here we have resistor.
Steady state means DC source, na, sir?
Steady state means? Sorry.
Steady state means DC source now, sir.
No, not does not mean DC only. Like steady state means now the circuit has reached some state where the values are like almost constant. Like whether it is sine is constant, but it will not have any time dependent expression like this. It might have sine cos because sine theta is what? It's a like sine wave, right? It is not increasing or decreasing. It is just a sine. So at steady state, meaning that no more changing in the values is happening. It can be DC like 5, or it can be sine like 5 sine theta, but no exponential terms are there. Like e to the power minus t beta is decaying, right? It will decay with time. So when we talk about t equal to infinity, this term vanishes. But if you say sine omega t, it is not decaying. It is just sine. Like it is not changing anything, but the waveform value might be changing, but the expression will not change.
So it's an AC source has both state, steady state and transient state now, sir.
AC source, like you cannot say that it has transient. Transient term is coming from basically exponential. So if there is no exponential term, then there is no transient. That's how we can say. So 10 ohm is 10 ohm, 4 ohm is 4 ohm. So now you tell me under which case this will fall, case 1 or case 2?
Case 2.
Case 2. So this will be say plus, this will be minus. Here also minus plus because the current is entering from the bottom. Now coming to the other one, it will be opposite minus plus. Here also minus plus. So first self-inductance is 3.6 in the S domain. It will be S into 3.6, right? So it will be 3.6 S and voltage will be into current, right? So I will write the voltage expression because it is voltage 3.6 S I1. Here also 0.9 S I2 because it's second current. Now coming to the mutual inductance, it is 1.8 S I1 and this is 3.6 S I2. Clear, everyone? How we are writing this? Sorry, this is 1.8 mm, my bad. 1.8 SI2. Last week it was J omega. Now we have written it S. Any confusion? Anyone? Any doubts?
Sir, that that second loop, current is leaving, right? So that we have written that self-inductance is minus plus 0.9 SI2.
Yes, yes. So it is entering from the bottom. So the bottom terminal will be positive.
But how this mutual, sir, mutual inductance minus plus comes, sir?
Oh, sorry, sorry. This is my mistake. Yeah, thanks for pointing it out. Yes, yes. Very much good. So this will be, yeah, thanks. This will be plus minus. Yeah, you are right. It will be opposite.
No, no, sir. Actually, that is right. You previously mentioned is right. I think so.
No,
But
no,
I'm
this is right
asking.
because it should be the opposite sign of self-inductance. Minus plus will be plus minus, right?
But the previous sum, the week 5 sum you have mentioned, right, sir? That is also.
See plus minus. Oh, sorry. This also, then okay, then this I have made mistake, right? No one has pointed out. It should be opposite, right? Minus plus will be plus minus. So you have not pointed out, sorry. So this is minus plus, so plus will come on top minus. Similarly, plus will come on top and minus. Yeah, sorry, my bad. If you see this is plus minus, it should be minus plus. Similarly, this is plus minus from the bottom, so it should be minus plus. Fine, right? Is it clear? I'm sorry for the confusion. I have said opposite sign, but I have written the same sign. I didn't check. Okay. So now this is fine, right? Hello, please respond.
Sir,
Yes, sir.
please show the previous one, sir. I
Okay.
will make a note, sir.
Okay. So I think now you have written the, I think, correct polarity only. It was my mistake. Now you just check in your calculation whether you have made the calculations correct or wrong. There could be some issue in the calculations or the expressions.
Okay, sir.
So now what will be the Laplace transform of 30?
30 by
30 by
S.
30 by S. Yeah, very good. So now let us write the expressions. So now that you are well aware with the KVL, KCL, I'll not spend time explaining that. I'll directly write the expression. If you have any query, you just stop me and ask.
Sir, in
So
what condition we should going to use Laplace transformation, sir?
you can use it anywhere.
Okay,
Say
sir.
if it is DC circuit, then Laplace is not needed. Because DC, inductor is shorted, capacitor is open, so there is no inductor and capacitor. So there you need not need Laplace. But wherever they're asking steady state or transient, you can use Laplace anywhere.
But here it's DC source, na, sir.
The source is DC, but it has a transient term, right?
So if it
The,
has only steady state, we shouldn't use Laplace, sir.
yes, yes. If they're asking steady state, then using Laplace will not provide you any benefit as such. So there is no need to use in that situation.
Okay, sir. Now, using this S domain, we should write KVL equations, sir.
Yes, yes. For this left loop as well as right. Okay. So 30 by S minus 10I1, then minus 3.6 SI1 plus
100 I want.
1 by 100. By 100.
How 10 I want, sir?
What is the voltage of a resistor?
Okay, sir.
Okay. So now from this, let us calculate I1 and write everything in terms of I2. So from this, I can calculate my I1 to be 30 by S into 3.6 S plus 10 because there are two terms plus 1.8 S by S into 3.6 S plus 10. Sorry, there is no S here. Into I2. Agree, everyone? This is just a math, so I hope everyone is following.
How you wrote that, sir?
I have taken I1 this side, and then whatever is the coefficient of I1, I have brought onto the other side. I have just skipped the math, but you should do. Everyone able to get the same expression? Or so if you see I1, you have to take to LHS or RHS side, and then bring its coefficient onto the other side, and then you will get this expression. Same. Okay. So now let us apply on the other side. So let me just take it to left side. So now let us write the expression in the loop 2. So we'll get minus 0. Let me use a black color only. Minus 0.9 ISI2 plus 1.8 SI1 minus 4I2 equals to 0. So now you will get 1.8 SI1 is equal to 0.9 S plus 4 into I2, right? Agree, everyone? Hello. Following? Are you? Hello, students.
Yes, sir.
Yes.
Yes, sir.
Everyone getting the same expression?
Yes, sir.
Okay. Because if you respond, then I'll go to the next step, else I'll stop there until you respond. Okay, now what we are going to do is we are going to substitute this I1 on the LHS side. So please substitute. I'll also write the expression right along with me. So 1.8 S, right? So SS will get cancelled. So 1.8 into 30 is 54. So we'll get 54 by 3.6 S plus 10 plus 1.8 S, 1.8 S, 3.24 S square by 3.6 S plus 10 into I2 is equal to 0.9 S plus 4 into I2. So now bring this I2 term on the other side. Okay, so you take this term onto the RHS side and then simplify. So we'll have 54 by 3.6 S plus 10 is equal to 0.9 S plus 4 minus 3.24 S square by 3.6 S plus 10 into I2 equals to 0. So now 3.6 into 0.9 is also 3.4 S square will get cancelled. So the rest of the terms, if you write, you will get 23.4 S plus 40 by 3.6 S plus 10 into I2. Just let me know once you reach this point. I have done a little bit fast. Just check whether you are getting this term or not. If anyone is not able to get, please let me know. And if anyone is getting the same expression, then also please let me know.
Same, sir.
Okay. So now in the denominator, if you see, we can cancel 3.6 S plus 10. Here also 3.6 S plus 10. And in the
So
numerator,
how do you got it?
sorry,
Previous step, how you got
which step? This first step or second step?
you substituted the diagonal equation in the left-hand side of the second equation. So
Yes. What is your doubt?
then next how you got that step?
This step, this is step 1 or this is step 2? Which step are you talking about? 1 or 2?
Step one.
Step 1, I have substituted I1 in this equation and then I got this expression. So you substitute this entire expression in I1 and multiply by 1.8 S and then you will get this expression.
After that, sir,
After this, I have taken this I2 term on the other side and then simplified them.
okay, sir.
Okay, one question let me ask. Are you also solving along with me, or you just like trying to understand the steps from the screen?
I'm solving, sir, but I'm solving only the first steps also.
Okay, then okay. So now what I'll be doing is I'll take 23.4 common so that I can write in terms of some s plus a. So from this, if you calculate, you will get I2 is equals to, so divide by 23.4 in the numerator as well as denominator, you will get 2.307 by s plus 1.709. So just check whether you are getting the same expression or not. I have just divided by 23.4 on both the sides, and then I have calculated I2. I2 is basically I2 of S, but I have removed that of S for simplicity because it is understood.
Same, sir. Same,
Yes, same.
same, sir.
Yes. So now we have to apply inverse Laplace transform. So we'll go back and see which one we have to follow. It is like 1 by S plus A, right? So it is in this format, right? Everyone agree? Our f of s is in this format, right? Hello.
Yes, sir.
Yes. So
Yes.
if it is e to the power at, you will get 1 by s minus a. Now if I have e to the power minus at, then you will be getting 1 by s plus a because a is negative, nothing. So now let us go back. So what will be the inverse Laplace of this one?
2.307 e power minus 1.7090, sir.
Yes, very good. 2.307 e to the power minus 1.7090. And as in the question, if you see, they always mention into u of t, meaning that before t equals to 0, it is 0. Because here, if you substitute some t negative value, it has some value, right? So that's why we multiply by u of t, saying that there is no value before t, because in the question they have said that the switch is closed after t. So before it is closed, there is no current. So that's why we multiply by u of t. So this is our one expression.
Once again, so U of t, sir.
So if there is no u of t and I ask I2 of t value at t equal to minus 10, it has some finite value, right? But if you go back to the question and see, they said that the switch is closed at t equals to 0. Before that, no current was flowing. So before t is equal to 0, meaning t less than 0, I2 and I1 should be 0. So that's why we multiply with a function which is equal to 0 before t equals to 0 and is equal to 1 after t equals to 0. So basically, this is not changing the value. It is just a making I2 of t 0 before t equal to 0, and it will remain the same value after t equals to 0. Got it?
It's U of t by 0 should come now, sir.
U of t by 0. Why u of t by 0 is infinite, no?
I didn't get how U of t is.
No. See, I'm
Sir,
saying
sir, U of t means that means U of t is lies between 0 to infinity. That means there is
okay.
no value between infinity to 0. That's why we'll put U of t. Because at t equal to 0, that current is 0.
U of t
We are switching.
and then t. Yes, you're right. So basically, the switch is closed at t equals to 0, and they're asking the value for t greater than or equals to 0. So previously, the current is 0, and after that, there is some finite current. But the expression that you are getting, it also has some value before t equals to 0. So it has to be 0, right? So that's why we are multiplying by u of t. So initially, it will become 0, and after t equals to 0, it has a finite value. Is that clear for everyone?
But they asked
Yes.
after t is equal to 0 now, sir.
But so now if you substitute t greater than 0, what is the value of u of t?
What's U of t in the question, sir?
U of t is a step function. It's a like known function. U of t is this function. Okay, U of t is like a well-known universal unit function, which is 0 before t is equals to 0. So for t less than 0, it is 0. For t greater than 0, it is 1. Like it's like universal. Like whenever someone mentions U of t, it means this function. Maybe I have not specified that part, but like it is this function U of t.
Then a t is equal to 1, what's U of t, sir?
T equals to 0, it is not properly defined. Sometimes people say t greater than or equals to 0, it is 1, and t less than 0, it is 0. Because there it is changing from 0 to 1. At that instant, you cannot define. But usually, most of the cases you will find for t greater than or equals to 0, it is 1. So at t equals to 0 also, they consider 1. But t less than 0, they'll consider 0.
So it will become 1, so we are writing U of t, sir.
Yes, yes, yes.
Okay.
Okay. So now I have gotten I2. Now I have to get I1. Okay. So this is my I1 and this is my I2. So now what we'll be doing is we will be substituting I2 in this, right? Agree? Or because this is lengthy, I can also substitute it here because I need I1. This will be making our lives much simpler. Okay, so you are getting right. Now I have to substitute I2 in this expression to get I1. Clear or any queries? Hello.
Clear, sir.
Okay. So now what is my I1? I1 is nothing but 2.307 into 0.9s plus 4 into I2 by 1.8 s into s plus 1.709. So if you further simplify this, you will get like 0.9 also I'm taking common and 1.8 also I'm bringing out. So you will get 1.1535 into s plus 4.444 divided by s into s plus 1.709. Just check whether you are getting this expression or not. So it is 1.1535. That is not s. This is 1.1535. 1 point. Just check if anyone is getting the same expression.
Same
Right?
expression.
Same expression. So now you have to apply partial fractions because in the denominator there are two terms. Now what we are going to divide is we are going to write it something like this: a by s plus b by s plus 1.709. Why? Because now I can directly apply inverse Laplace transform. So in order to apply inverse Laplace transform, you have to write the things in a specific way. So because the denominator is first order, meaning only s term, the numerator will have only coefficient. So I hope you know partial fractions, right?
Numerator also we have S terms, and then how can we solve, sir?
Uh, like we'll see. Like if you see on the black color, there is s term in the numerator. But if you simplify the red color term and write in terms of numerator as well as denominator, then in the numerator also you'll get a s term, right? Agree? Like as plus 1.709a plus bs. That is what you will be getting, right? I mean to say, expand this. What you will be getting? As plus 1.709 a plus bs by s into s plus 1.709. Agree? This is what we'll be getting, right?
Yes, sir.
Yeah. So now compare LHS and RHS. You will get two equations. One equation is a plus b equal to 1.1535. Another expression is 1.709 into a is equal to 5.12667. I'm just comparing the coefficient of s and the constant term. So once you do this, solve for a and b, you will get a equal to 3 and b equal to minus 1.8465. So I have just skipped the math, but I want you to do. So I'll just wait for a few minutes before you solve. So I have basically compared S coefficient of both the terms as well as the constant term. So A plus B is 1.1535, 1.709A is what? 4.444 into 1.1535.
I'm not getting how you equated, sir.
So,
What's in
sorry.
LHS side?
So
What's in
this,
LHS side, sir?
so this I have equated basically uh, this term and this term. So denominator are same. So now we have to compare numerator. So in the numerator, you will compare the coefficient of S and the constant on the LHS side with the coefficient of S and constant on the RHS side. So coefficient of S is what on the LHS side? 1.1535. And coefficient of S on the RHS, it is A plus B. So both I have equated. And what is the coefficient on the LHS side? 1.1535 into 4.444, which you will get 5.12667. On the RHS side, what is the constant? 1.709a. So those two equations will give rise to these two equations.
Denominator also has coefficient, sir.
But denominator are same, right? They'll get cancelled. Both are same, right? I can cancel it out. Like denominators will get cancelled, right? You will be left with only numerators. Everyone is getting the same coefficients, or anyone has any queries? Hello.
Same, sir.
Same, right? So now if I write I1, I can write my I1 as 3 by S plus minus 1.8465 by S plus 1.709. So now apply inverse Laplace transform. You will get I1 of t is nothing but 3 minus 1.8465 into e to the power minus 1.709 t whole into u of t. Agree, everyone?
Yes, sir.
Basically, u of t is also same u of t. So this is my I1 and this is my I2. Okay. So now let us see. There is less than a minute. I think this meeting will end. But before that, let us quickly check the answers. So they are asking A1. What is A1 here in I1 of t? This is A1, constant term. Or let me do one thing. Probably this meeting will end before we complete this problem. If it ends, please join back. Okay. So tell me what is A1? Sorry. If this meeting ends, please join back. 3.
3, sir.
What is B1?
Minus 1.8.
What is A2? Anyone?
0, sir.
B2?
2.307, sir.
And what is tau? Careful with the tau, huh? Anyone, what is tau?
Point 585.
0.535.
585.
585. So these are the expressions that we are getting. Let us quickly go and cross check. So A1 is 3. So A1 is 3 in the range. And B1 we are getting minus 1.8465. Minus 1.8465 we are getting. A2 is 0 simply. B2 is, we were getting somewhere in the range 2.307. So it is also in the range. Tau 0.585. So it is also coming in the range. So before we proceed into the other problem, let me just quickly summarize. If you have any questions, you let me know. So in this problem, it's a mutual inductance term. So whatever we have learned the concept in the last week, first we have applied it and drawn the equivalent circuit. Then we have realized there are two unknowns, so we need to get two equations. So we have applied KVL in the loop 1 as well as KVL in the loop 2. After getting two equations, we have substituted one in the other, and we have solved for I2 of t first. And then once we get I2 of t, we have solved for I1 of t. So once we have gotten both the expressions, then we have cross-checked what they are asking, and then we got the terms. Any doubts until this problem?
No, sir.
Okay. So probably I'll not get time to solve two more problems today. This problem and this problem. This is simple because it is just series RLC. You'll be able to do. But this is a somewhat tricky problem. You will see why I have said it is tricky. Because it has sine terms, and sine terms are always tricky. If you see, sine term is the steady state term and exponential term is the transient term. So again, it is also like a transient question. So we have to apply Laplace only. If you see, there are only R, L, and C. So it's a second order system. So every time you see any question, you have to first write in the Laplace domain. So what is the Laplace domain of inductor here? In the frequency domain, what is the value of inductance? Hello.
18s.
18s. And if you see, capacitance has initial condition, so that's why I have covered that concept earlier. So now this is 18s, and resistance will remain resistance 270, and this is I1 of S, and this is I2 of S, and this is I1 plus I2. What will be the capacitance? And initial condition is 50, so this will be 15 by S. And this entire thing will be VC of S. Not just across the capacitor, because capacitor we have broken down into two terms. Now entire term will be VC of S. Okay.
How 15 or 15 base?
15 because they have initial condition. This is the initial condition. They have mentioned 15. And if the initial condition is VC of 0, and then we are converting into Laplace domain, we have seen that it is V of 0 minus by S. So the same thing we are following over here, which is 15 by S.
Yes, sir.
Okay. And what will be the capacitance term, anyone?
1 by S into 1 by S into 1620, sir.
So
Sir,
1620 will
S divided
be
by 1620. S divided by 1620.
okay. Like even I have made a mistake while I was solving. So just cross check. So if it is capacitance is C, what will be in S domain? 1 by or S by?
1620 S.
Sorry.
1620 S.
No, no. If the capacitance is C, what will be the S in the S domain? What will be the value in terms of
1
C
by
and D?
CS, and it will be
1 by
1620
CS,
by
right?
S.
Yes, very good. It will be 1620 by S. So even I made a mistake and then I have cross-checked later. 1620 by S. Okay. Okay. So now let us quickly
Sir,
solve. Yeah.
sir, the V0 will make the polarity similar to the given polarity of VC, which
Polarity.
is given
Yes.
question.
Yes. Because
Okay, sir.
they have
Thank you,
mentioned
sir.
this polarity and they have not mentioned anything about this. So we'll consider the same polarity. Yeah.
Sir, if you would wear minus 15, then
If they have given minus 15, I'll consider the same polarity and I'll put minus 15 by S.
okay, sir. Thank you, sir.
So now if you see what is the voltage across inductor and voltage across the resistor, both are same, right? So what is the voltage across inductor? So this is plus and this is minus. In terms of 18S and I1, what is the value?
18 S I1.
18S I1, very good. And what is the voltage across resistor?
So we shouldn't take L into di by dt as.
No, it is now like if you go back in the very beginning, so that L into di by dt is in the time domain. Once we get here, it is just voltage equal to current into SL, voltage equal to current into 1 by SC, voltage equal to current into R. So all are algebraic expressions only. So there is no time domain business and there is no differential terms also. So it becomes very simple. So that is the advantage of Laplace. So what is the voltage across resistor?
Okay.
270 I2, sir.
270 I2. Yeah, very good. 270 I2. So now if you calculate, eliminate I2, we will get 18S I1 by 270, right? 18S I1 by 270. So if you cancel 9 30s and 9 2s, so it will be 15, right? SI1 by 15, if I'm not wrong.
Yes.
Okay. So this is my equation 1. So again, VC of S is equals to 18 SI1, right? Like voltage across inductance is what? 18 SI1, right? So 18 SI1, the same voltage is also across the combination of this 15 by S and 1620 by S, right? So I can write 15 by S minus 1620 by S into I1 plus I2. Basically, what I have done is this voltage and this voltage I have compared because both are same. So one voltage is 18 SI1. Another voltage, if I'm going from bottom to top, say this is my ground, then it will be plus 15 by S. And then we are going in the direction where there will be potential drop because we are going in the direction of current and the impedance is 1620 by S. So into I1 plus I2. Any confusion or is it clear?
Minus 1620.
Sorry. Hello.
Oh, then minus 15 S should come as well.
No, we are going from lower potential to higher potential, right? So when we are going in that direction, we are going to a higher potential, right? We are going to the plus terminal.
Plus 1620 by S should come as well.
Because if you see, we are the current direction is this one, right? So if the current direction is this, then for the capacitor, this will be at a higher potential, this will be at a lower potential. So basically, in the current direction, we are going for that capacitor element, we are going to a lower potential, but the voltage source is a different thing because voltage source it is independent of current. So in the case of voltage source, you are going to the positive terminal of the voltage source. So there is a gain in the voltage. For the capacitor, you are going in the direction of the current. So you are going to a lower potential terminal. So that's why minus.
If there is current source, we should take minus down plus up.
Yes. And yeah, like whenever you are going to a higher potential, it is positive. Whenever you are going to a lower potential, it is minus. Okay. And I have seen like you are still confused about this polarity because we are already in the week 6. If you are still confused about the polarity, then like you will make more mistakes. You should again thoroughly check the basics in our earlier weeks, because at this point of time, it should be like you should be comfortable with the polarities, because if you are still little bit confused, then you might make mistake. Right. So you have to be very careful with the fundamentals. You just cross check with the fundamentals again. Fine. Okay. So what we are going to do is we have another equation here. So that is our equation 1. This is our equation 2. So let us substitute I2 in this expression. Then you will be getting 18S I1 equal to 15 by S minus 1620 I1 by S. Then minus SS will get cancelled. 1620 I1 by 15. Agree, everyone? And this will be 108. So let me simplify. This is 108 I1.
Yes, sir.
Yes, right. So now what I'll do is I'll take I1 terms aside and then the other term aside. So I'll get I1 into 18S plus 1620 by S plus 108 equal to 15 by S. So now let us simplify. We'll get 18S square plus 108S plus 1620 by S equal to 15 by S. And then SS will get cancelled. Now if you rewrite this expression, you will get I1 equal to 15 by 18S square plus 108S plus 1620. Agree, everyone? I have just did the math and I'll give you time. You got it?
Yes, sir.
Okay. So now what we'll do is let us divide the numerator and denominator with 18. So now what we'll be getting? We'll be getting I1 equal to 15 by 18 in the numerator. And if I'm not wrong, it will be 0.833 by S square plus 6S plus 90. So very interesting thing. Every time you get S square in the denominator, you have to keep one thing in mind, that every time if there is S square in the denominator, then you should be either getting sine term or cosine term, because only these two terms will have S square in the denominator, like for sine as well as cos. So here S square, here S square. So you have to write in terms of S square plus A square, or in the format of some S plus A square plus B square. So this is what that should come immediately into your mind, because in the denominator S square is there, means either sine or cos. So you have to segregate the S term as well as the constant term. So you have to write some S plus A whole square plus B square in that fashion. Because I know the Laplace transform, then only I can do this. See, if I don't know the table, then I don't know how to solve this, right? So that is the bottleneck. So one should be thorough with those tables, and yeah.
So the final expression is 0.833 e to the power minus 3t cos 3t.
Okay, okay. Just wait. Let us. Maybe you are right. I'll come there. Probably you are right. So everyone agree with this expression?
Yes,
Hello.
sir.
Okay. So now what I'll do is 0.8333. Denominator I'll write s plus 3 whole square plus 9 square. Okay. And then here I'll make one small thing into 9 by 9. Why I am doing, I'll just let you know. So 0.8333 by 9 is what? It is 0.09252 into 9 by s plus 3 whole square plus 9 square. Agree, everyone? Why I have written? Because you have to see and you have to write in the same format. So you have to write, I am writing in this format, b by s plus a whole square plus b square. Because in the numerator also b is there, right? I cannot ignore the numerator. Entire expression should be there. So in the denominator, if I have s plus a, it means e to the power minus 80 sine bt. So I have written that expression accordingly.
I didn't get
Which part you did not get? This first top step or the bottom step?
black color.
Black color. Okay. Okay. Someone was asking something. I think Parvatam or Samhita. Someone was asking. Who was asking? Shamita. So
So
s square
how
plus
s
6s plus
plus
90.
9?
So if you simplify this term, you will get this term, right?
How to find that the from the distribution?
Okay. So basically, we have used this formula a plus b square equal to a square plus 2ab plus b square. So here a is s and 2ab is what? 2 into 3 into s. So b is what? 3. So from there, you can write it as s square plus 6s plus 9 plus 81. So then we have written this as s plus 3 whole square and this as 9 square.
No, sir, from s square plus 6s plus 90, how you found that is s plus 3 whole square plus 9 square?
That's what I have told. Na? A plus b whole square is a square plus 2ab plus b square. Na? If a square is equal to s square, what is a? S. So if a is s, 2ab is 6s, what is b?
3.
3, right? So b square should be 9. So I have taken 9 from this and I have written 90 as 9 plus 81. So this term has become s plus 3 whole square, 81 has become 9 square.
Okay.
Okay. And then we have to write 9 in the numerator also, because if you see in the Laplace transform, 9 is there in the numerator also, because b is there in the numerator. If it is sine, b will be there in the numerator. If it is cos, s will be there in the numerator. So what we have done, whatever b 9 is there in the denominator, I have multiplied in the numerator and then I have simplified it. So now I know that this is what e to the power minus 3t cos 90. So I can directly write my I1 of t. Getting it, everyone? My I1 of t I can directly write as I1 of t equal to 0.09252 into e to the power minus 3t cos 90. Again, we'll multiply by u of t for the same reason that before t equals to 0, it is 0, and after t equal to 0, whatever value we are getting. So is this clear, everyone? So it is ampere. So I'm writing the unit ampere.
Sir, is it sine, right, sir?
Sorry. Yeah. Thanks for this sine 90. So now let us go back to question and see what they're asking. So I1, they're asking in terms of sine. So there is no issue. phi 1 will become 0. So now we have to calculate I2, we have to calculate VC as well. So I1 of S. So this is my I1 of S, right? So this is my I1 of S. Okay. So I1 of S is obtained. So now let us see which one we can solve. If I1 is known, I2 can be found easily. Also, they're asking VC. VC is the overall voltage, which is also 270 into I2. So once we calculate I2, we can get VC also. So the first thing that we have to find is I2. So let us find I2. Okay. And we'll use this. Or better, we'll use this expression. Okay. So substitute this I1 here. Okay. Clear or any queries?
Yes,
Hello.
sir.
Clear. So now basically we are finding I2 of t, right? So let us just write I2 of t. So 0.8 triple tree by 15 is there, right? So what will be that term? 0.8 triple tree by 15. So what is 0.8 triple tree? If you see 0.8 triple tree is nothing but 15 by 18. So if you do this by 15, you will get 1 by 18. Something like this. Because this term is nothing but this term is 15 by 18. So 15 will get cancelled and we'll have 18. So 1 by 18 into S by S square plus 6S plus 90. Clear? Any doubt? Clear, right? I have substituted I1.
Yes, is there, sir. Yes, I1 by 15.
Yes.
Where did you go?
So S into I1 by 15. So I1 is 15 by 18 by S square plus 6S plus 90. So if you substitute that, 15 will get cancelled. Only 1 by 18 will be there. And rest of the term I have written in the brackets.
Okay.
Okay. So now I have told you, if in the denominator you have quadratic term, then it will have sine or cosine term. But for sine in the numerator, it is constant. But for cosine, you will have s. And what term you will have? You will have s plus 3, not just s. So what I will be doing is, I will be adding plus 3 and then subtracting minus 3. I mean, adding 3 and subtracting 3. And then I will write it in this way, 1 by 18, right? S plus 3 by denominator, so you already know s plus 3 whole square plus 9 square. So I'm skipping. And then minus 1 by 3 into 9 by s plus 3 whole square plus 9 square, right? So minus 3, what I have done, I have written 9 by 3 because I need 9 in the denominator for this to be sine. And here I need s plus 3 in the numerator to make it cosine. Any queries? It is just a mathematical manipulation. Sorry.
9 how came, sir, in numerator?
It is supposed to be 3, right? So 3, I have written 9 by 3.
Okay.
Why I have written 9 by 3? Because I need 9 in the numerator, right? So I have multiplied by 3 and divided by 3. So basically it is nothing but 3. If you cancel it, it is minus 3 and minus 3 plus 3 will get cancelled. So you have this term. So I am writing the term in a different way so that I can get cos and sine terms. Fine or still some confusion?
Fine, sir.
So you're going fast, so I can't solve it
Sorry.
mathematically. You're going so fast, so I can't solve it mathematically.
Okay, I'm going a little bit fast. But till here it is fine, right? Because I'm going fast because we are running out of time. That's why. But I'll keep that in mind. And you should also practice along with me. Then only you'll pick up the pace. Till here, everything is fine, or still you have confusion? Basically, we have to write the terms in a way so that we can take back to cos or sine when we apply inverse Laplace transform. So that is the basic law, fundamental logic. So on top of that, you have to do some mathematical manipulation. And this is that's why I have skipped that math part, but I'll keep that in mind and I'll try to go a little bit slower. But till here it is fine, right, Shamita?
Yes, sir.
Okay. So now let us apply inverse Laplace transform. So can anyone help me with the expression?
Sir, 1 by 18.
I2 of t equal to 1 by 18.
It is power minus 3t.
Okay. E to the power minus 3 I'll take common
Cos,
because both have same.
cos 90
Okay.
minus 1 by 3 sin 90.
Sine 90. Very good. So now let me take the 3 also outside. Okay. So then I'll have 1 by 54 e to the power minus 3t 3 cos 90 minus sine 90. Right? Agree everyone? If you go back to question, I have to write sine of omega t plus phi 2. So I have to combine this both the terms. Okay. So I'll be combining how? I'll multiply by root 10 and then divide by root 10 because 3 square plus 9 square. Again, so if you see here we have 3 square plus here 1. 1 is there, right? So 3 square plus 1 square is root 10. So that's why we'll multiply by root 10 and divide by root 10. Then my I2 of t will be root 10 by 54 into e to the power minus 3t. So it is 3 by root 10 cos 90 minus 1 by root 10 sine 90. Is this clear? Why I have written this? Because I can consider this as sine theta and then I can consider this as cos theta. That is the only purpose why I am multiplying by root 10 and dividing by root 10. So Shamita, are you able to follow?
Yes, sir.
Yes, right? Like now it is clear, right?
Why sin theta and cos theta?
Because I want to write in terms of sine omega t plus phi 2. I know that sine A, so I know that sine of A plus B equal to sine A cos B plus or say minus. Let us put sine of A minus B. Sine of A minus B is sine A cos B minus sine B cos A. Right? Here B is what? B is 90 and A is what? A is theta. So I am just using that formula. Clear? If you calculate theta, you will get theta to be 71.565 degrees. Clear, right? Everyone?
No, sir.
Which part you are not clear?
How sin theta and cos theta came, sir?
I am assuming if say sine theta is 3 by root 10, what will be cos theta?
Sin inverse 3 by root 10. Cos of sin inverse 3 by root 10.
Yes. Or if you use sine square theta plus cos square theta equal to 1, cos theta is 1 minus square root of 1 minus sine square theta, right?
Yes.
So if you do that, you will get cos theta is 1 by root 10. So if this is sine theta, that will become cos theta.
Okay.
So now I can write in terms of sine A cos B minus sine B cos A. So if you simplify that, you will get I2 of t equal to root 10 by 54. That is nothing but 0.0585. Okay. Into e to the power minus 3t. Okay. And then sine of what is theta minus 90. Right? Okay. But if you see in the question, they are not asking theta minus 90. They are asking omega t, right? Omega is 9. So they want omega t to have a plus sign, right? Not minus sign. So we have to transform this expression. So till here, everyone got an idea, right? What is I2 of t expression or any confusion? Any doubt, anyone? Clear, right? Or confusion,
So
any?
theta value. So how do you get the theta values?
So theta value, you can get sine inverse of 3 by root 10 or cos inverse of 1 by root 10 or tan inverse of 3. So I can write this as tan inverse of sine theta by cos theta, which is tan inverse 3. So I have used calculator to get this angle.
Clear.
Clear, right? Now I'm simplifying this sine theta minus 90. So sine of theta minus 90, I can write it as minus of sine 90 minus theta. Agree, everyone?
Yes, sir.
Yes. So if it is minus, then it will be minus 0.0585. But if you see in the question, A1, A2, AB are positive. So it cannot be negative. First of all, this cannot be negative, and I want sine omega t having a positive coefficient. So neither I can write in this format, nor I can write in this format. So now what I will use? I will use sine of 180 plus theta equal to minus sine theta. So that I will be using. So minus sine theta is what? Sine of 180 plus theta, right? So I am going to use this identity. And once you calculate, you will get sine of 90 plus 108.434 degrees. So basically, I am just writing the same expression in a different way because in the question they have put some constraints and I have to write the answer following those constraints. So now let us write I2 of t. So I2 of t equal to 0.0585. Shamita, are you following?
Yes, sir.
Okay. Clear or confusion? Any confusion?
No, sir. Clear.
Okay. Okay. So this is my I2 of t. So everyone got this I2 of t, why we are getting or how we are getting? Clear or any queries?
No, sir.
Okay. So now if you see what is the value of this VC in terms of I2 and 270? What is VC of S in terms of I2 of S and 270?
VC is I2 into 270.
I2 into 270, right? So now I can write directly V2 of T is equal to, because if I directly apply inverse, then V2 of T is 270 into I2 of T. So I need not do any calculation. I can directly write. So V2 of T is 270 into 0.0585. So you'll get 15.795 e to the power minus 3t sine of 90 plus 108.434 degrees U of t ampere. Clear? This expression? Voltage. Yeah. Thank you. I was in a hurry. So this is voltage. Yeah. Thanks for pointing it out. Okay. So let us write all the expressions that we got. So first we got this I1, and I2, and V2. And let us go back to question and see what they are asking. So they are asking these expressions. Okay, or we can write it here also. So what is A1? Anyone? What is A1?
0.09252, sir.
0.09252. What is A2? What is A2?
0.0585, sir.
0.0585. And what is A3? So Nandini says 0.0585. Yeah, correct. What is A3?
This AV, right, sir? AV
Sorry,
15
AV,
points,
AV, yeah.
15.9 for 79.
Yes. There is less than a minute, so if this meeting ends, kindly join back. We'll complete this problem. AV is 15.795. Okay. And what about omega?
9, sir.
Omega is 9. Okay. And what about phi 1, phi 2, phi b,
It's 510, sir.
phi 2? You have to calculate in radians, so please calculate. Phi 2 and phi b are same, so one only you have to calculate. I think this meeting will end. Please join back. We'll just complete and summarize today's session.
17.25.
108.434.
Okay. So what is phi 2, phi b? You have to convert it into radians. So you have to do into pi by 180. Anyone?
1.892, sir.
1.892.
1.892 radians. Okay. So it is not 0 degree, it is also 0 radians.
Why we should convert into radians?
Because in the question they have mentioned omega is in radians per second and phi is also in radians. 1.892. You saw, right? In the question they have mentioned.
Yes, okay.
So here they have, so all this you have to follow. Here, this is radians per second, this is radians, and this is greater than 0. So that's why we were trying to change. So first thing is theta minus 90, I can write it as 90 minus theta because they need omega t, right? So it is valid. But if I write minus sine 90 minus theta, then the coefficient will be minus of 0.0585. They have said that A1, A2, A3 should be positive. Then what will happen? I cannot write in this way because it has to be positive. So I have to write in a different way. So I have used another term and then I was trying to follow all these things. So again, there are this condition also. So one is, this is in radian, sorry. This is in radian. The coefficient is positive and phi also minus pi to pi. Say if you got some other value, say more than 180, say 240. 240 can be written as minus 120. So you have to make those minor changes and then check. Okay, let us check A1. A1 value is 0.09. 0.09. It is in the range. Phi 1 is 0. And A2 is 0.0585. 0.0585 in the range. Phi 2 is 1.8 in the range, right? How much? 1.892. And what is AV? AB you got 15.795, 15.795, and 5 is also 1.892, 892. K you got, oh, K we have not written. Omega we have written 9. What is the value of K, everyone? We forgot K.
3, sir.
3. So K is 3. So K is 3, omega is 9. K is 3, omega is
So
9.
minus minus 1.18 in radians.
Which one? Which one?
In question they said from minus pi to pi.
Minus pi to pi, yes. Minus 180 to 180.
In radians,
So in the angle, it will be from minus 180 to 180. So in terms of radians, it will be minus 3.142 plus 3.14.
okay.
Okay. So any questions in this, any queries in this question? Okay, if you don't have any queries, let me just summarize. So in this week, we have studied about circuit analysis with Laplace transform. First, we have seen why we need Laplace transform, because it not only gives us tangent and steady state expression, but also it will simplify the analysis, because all the differential equation will become algebraic, and we can also apply all the mesh and nodal analysis. If you see, we have applied KVL, KCL, everything today. So it is equally applicable. And this is the expression to get Laplace transform of any function, although you will not be using in this course. I have just given you for some idea. And this is the table. One should be very thorough. One should remember this. So then you can solve the problems easily, because you will be applying Laplace transform. Also, you'll be applying inverse Laplace transform. So one should be thorough. If you are thorough with this, then you will know which expression to be used. Say if we have denominator s square, then you will get either sine or cos. If it is s, you will get exponential. So these things you should be thorough. And if it is differential, it will be s to the power n. If it is integral, it is 1 by s. And then we have seen RLC, how to write it in Laplace domain. So the differential term that was there in the time domain will be converted into an algebraic expression in the case of Laplace transform. And inductor with initial condition, capacitor with initial condition, how to write we have seen. And the polarity as well as the direction of the current is very important. That we have checked one assignment 5 query. And sorry that I have made this mistake. Kindly be careful with the polarity before starting the problem. Then we have seen one problem in the same case, like the mutual inductance. First, we have drawn the circuit. Then we have applied KVL in both the equations, two equations, two unknowns. We have solved for I2 first, and then we have applied inverse Laplace transform, and then we have solved for I1 and applied inverse Laplace transform. In the other case, we have RLC network, parallel RLC network. So second order. First, we have converted everything into single unknown, because two equations, two unknowns. First, I have calculated for I1, and then you have to reframe the expression in such a way that you can directly apply inverse Laplace transform. So please be careful while applying inverse Laplace transform. Don't make any mistake. Here, numerator should be 9. It cannot be 0.8333. So numerator has to be 9. So that's why I have multiplied into 9 by 9. Okay. Then you will get this expression applied
Where
inverse
the
Laplace
another
transform.
line
Sorry.
denominator line.
Sorry.
Okay, so I got it. So
Okay. So then I got I1 of t. Then I have used I1 into I2. And if you see here, we have numerator s. But for cos, you have s plus 3. So I have added plus 3 minus 3. So s plus 3 will become one term. And minus 3 will become another term. But if you see again, I need 9 in the numerator. So what I have done minus 3 into 9 by 9. So 1 9 will be in the numerator. 3 by 9 is nothing but 1 by 3. So this is what we have done. And then this term will become cos, this term will become sine. And after doing this, again, I have to transform it into a different way using sine theta, cos theta. So I can write this as sine of a minus b. Even after doing that, I have to change, because in the question, they have asked 9t, not minus 90. 90 should be positive because omega is 9. So I have used sine of theta is minus of sine minus theta, but still this cannot also be used, because in this case, coefficient is negative and they have said it has to be positive. So I have added I have used sine 180 plus theta is minus sine theta identity, and then I got the expression. Once I got I2 of t, then I have calculated V2 of t, and then I got all the expression, and then I have compared. Please be very careful with this. whatever they have mentioned, you have to strictly follow, else you will not get marks, you will lose marks. So you have to see what conditions they have mentioned in the question, and accordingly you have to solve and get the expressions. So that is all about this week, week 6. If you have any queries, you may ask, else we'll meet in the next.
So sin 180 plus theta again it would be sin minus sin theta also.
Yes, yes. So sine 180 plus theta, right? So 180 plus 90 minus theta is minus sine theta. So now if you see this expression, omega t, omega is positive, and sine coefficient also positive, phi is also minus 180 to 180. So sine of theta minus 90, I have written sine of 180 plus 90 minus theta, obeying all these conditions. If you write in this case, it is not obeying because coefficient is negative. If you write in this expression, omega is minus 9, but omega is 9, right? Because all the omegas are same. If here you get 9, here also you will get 9, here also you will get 9. You are just writing in a different way, but the expression has to have same omega. So it cannot be minus 90, it has to be plus 90.
Okay.
Okay. Any other queries from other people?
Yes, sir. Yes, sir. Please only one time
No,
repeat the
sir.
week assignment, that plus
Your
minus.
voice is very low. Parvatam, can you speak louder?
Sir, please one time repeat that last week's problem. Plus minus, I have some confusion, sir.
Okay. So let me just quickly repeat it. If you see first the self-inductance term. So this is plus, this is minus. Here also current is entering from the bottom. So plus on the bottom, minus on the top. Now because it is case 2, the mutual inductance will have the opposite polarity. So if this is plus minus, this should be minus plus. And this is minus plus, so this should be plus minus. And same is equally applicable because both are under the same case. Yes, now tell me what is your query. And this problem is also same, like plus minus minus plus, plus minus minus plus. This also same, plus minus minus plus, plus minus minus plus. Clear or still some confusion is there?
Yes, sir. I have also used the same plus minus, but I got a wrong answer. That's why, sir.
Okay. So one thing that could possibly have happened is your equations might have some mistake, not the circuit. So just check once and we'll see what happens, because solving that weak problem again in this session will kill time, and now we are also running out of time. So just check your equations once again, or you can talk to the other students if you know. Just it's the equation and math. If you have written the circuit diagram correctly, try to solve it once again, or they will also share the solution. You can also check the solution.
So the current is leaving from the last loop, sir. Current is leaving, right? So minus plus, isn't it, sir? 9.6 I2.
So current is entering the bottom terminal, right? So current is entering the bottom terminal means the bottom is plus and this is minus. And because it is case 2, if it is minus plus, it should be plus minus, opposite of this. Same, like this case, and today's problems case all are same.
Okay, sir. Thank you, sir.
Okay, then if you don't have any queries, then we can end this session here today. I hope you got benefited from this session and you have understood the concept and how to apply for the problems. Thank you, sir. Gyanendra. Okay, thank you, Gyanendra. Okay, with that, we can end this session here. Thanks for joining and thanks for being interactive. The Nandini is saying thank you, sir. Yeah, thank you. Thank you very much. And I wish you all the best for your assignment 6. We'll meet again in the next week, Monday, 6 to 8 p.m. with week 7 content. Prepare well, solve as many problems as possible. Don't make any mistakes. Try to rectify your mistakes while practicing only and not in the assignment. Okay, I wish you all the best and good night. I'll try to upload a video. Maybe today it will be a little bit late because I have some other work, but I'll try to upload it by tonight itself. Please go through the videos and please understand the concept thoroughly and solve as many problems as possible and do well in your week 6 assignment. Okay, with that, we'll end this session. Good night, everyone. Thank you for joining.